To the next speaker, it's Dr. Mark Fišel from the University of Tartu. Mark Fišel is the head of the chair of natural language processing at the University, at the Institute of Computer Science of the University of Tartu. His research is mainly in applying machine learning methods to computational modeling of natural language. And his presentation is zero-shot monolingual and cross-lingual style transfer. Please go ahead.
Thank you very much for the introduction and good afternoon. It's an honor to be presenting to all of you. Let me see if we can call up my slides. So, I'm representing the University of Tartu to you today. And when I looked at the program, I realized that my talk or my topic falls out of the whole list because I'm mostly focusing on a couple of specific examples from my chair. So instead of, let's say, talking about value of research or the best practices within collaborations between industry and academia. So I cannot but agree with Professor Skubarsev's general conclusions that science, well, maybe I'm paraphrasing, but science is best done when applied to real-life problems, and it is helpful when those real-life problems come from the industry. And yeah, but next I will give you a specific example of my chair of natural language processing from the Institute of Computer Science at the University of Tartu. Is there a delay in the slides? So maybe I'm not clicking it. Yeah, so what a large part of my chair is working on is actually support for the Estonian language in the face of collecting linguistic resources and annotating them with the necessary information or data in order to do linguistic studies and computational linguistic studies there. So another smaller part of the chair also works on developing methods of natural language processing that would not require linguistic resources or having them annotated. And applying them all over. So there is sort of a conflict between those two, but this arose from a situation some 15 to 20 years ago where there were no linguistic resources for Estonian, and these were the two paths that we could have taken. So either develop methods that do not depend on those resources or start collecting those resources for Estonian. And so we continue doing both. But in parallel with that, of course, the main focus, covering both of those, the main focus of my chair is research and publishing and research projects. But in parallel with that, we of course do research and development activities, and we collaborate with industry, and we also develop prototypes and services that are used by some industrial partners and by users online. So, and some examples of those practical applications and demos, one would be our recently developed Estonian text-to-speech synthesis, so an application where you type text and it can generate the speech corresponding to this text. And this was automatically trained using 7 presenters from the Estonian radio, so Meelis Kompus and 7 more there. And with this one and the same trained model with neural networks, we can synthesize whichever text anybody types with whichever voice that you can select online. And it's available online through neurokõne.ee, or if you're foreign, you don't have Ö on your keyboard, you can just type O. Then another example would be the translation application we have, which is neurotõlge, or neural machine translation. So here it has this interface of, well, typing sentences, and you can either translate them or you can click play, where you actually, instead of just translating them, you see translations by 3 different translation motors. One is ours, one is by a company called Teaduste, which exists in Latvia, also Estonia and Lithuania, and one by Google. And in order to collect unbiased feedback to which translation is of the highest quality, we then scramble the order and ask the users to click on the best one, and that way we see which one is the best. So in this case, there was a lot of ambiguity in the Estonian source. It included a word mais, which in this case means in the month of May, but otherwise can mean corn, and also in lands. And here, well, it just happened that our engine was the best in this case, and so it says talking about the weather, the rains can be expected in May, or, well, I cannot read from here. But so mais is also incorrectly translated as corn, or satu is incorrectly translated as hundreds instead of rain on the other ones. Of course, these examples of our engine being best is quite scarce. Usually, well, I mean, this is more of a cherry picking than a general trend. And another application we developed is live subtitles. So this is actually a collaboration between Tallinn Technical University and their Laboratory of Phonetics and Speech Technology. Can we? Not touching? No? Come back, please. There. No, so let's go on. Okay, I'm not sure what's happening. So the application you should be seeing here is actually automatic transcription of Estonian speech into Estonian text. So on the left, so you see Margit Sutrop there talking at the conference of the mother tongue. On the left is the Estonian transcription. Maybe. So, I mean, yeah. Maybe some technical help from back there, so we're not seeing anything here. It doesn't like this slide. So on the right, you see the automatic transcription into English of this translation. It's not 100% precise, but it gives a nice idea of what it's being, what is being talked about. So maybe this slide will appeal more to the machine. Yeah, so how machine translation works is actually by predicting word by word the output that it should produce, and this is actually, it follows the same principle as Professor Lopriena before mentioned. So instead of saying the translation is correct or incorrect, we just say that this word is more plausible or less plausible. So we estimate the next word's probability distribution, and here it's of course synthesized here, not a real example, but mice could be translated as in May, or could be all blacked out, or could be translated also as corn or other words there. But the exact application I actually wanted to show you is, so machine translation learns from data. So we show it a lot of examples, like here, tere translated into hello, and kuidas läheb translated into how you're doing. But this is about it. So we need annotated examples. So we need specific examples of what to predict. Now, one experiment that has been done by our colleagues in Google was actually training one and the same translation model to translate for multiple language pairs. So this model would learn to translate from Estonian to English and also from Italian to Latvian. So it sees examples like tere translated into hello, but also sees buongiorno translated into labdien, or il mio gelato translated into mans saudējums. And of course, in order for it to know into which language to translate, we give it a marker of 2 English or 2 Latvian there. And the best result out of here is that this learns to translate for language pairs it has never seen. So from Estonian into Latvian, or from Italian into English. So this is exactly where our application comes from. So the task we tried to solve, and this was the original title of my talk, style transfer. So taking a sentence in a natural language, like something like, hey, what's up? And changing the style while preserving the meaning, and generating something like, hello, how are you doing? And this can be done monolingually within one language or cross-lingually. But the problem with this is, of course, there is no data. So for machine translation, there are millions and millions of examples of translations done previously in the European Parliament for subtitles, for TV, for other events. While for this kind of style change within one language, there are no direct examples in large amounts from which the same methodology could learn. So what we did is actually we noted that, well, there is the kind of data where we have Estonian subtitles translated into English subtitles, and then Estonian legal text translated to English legal text, or Estonian European Parliament speeches translated into English, and so on. So the solution here is to pretend that each of those text domains, subtitles or legal text or others, are actually languages, and then to treat them as separate languages, and to train the machine translation system to translate from English, or from Estonian subtitles, let's say, into, well, English subtitles, but then to ask it to translate subtitles into legal text, or let's say speeches into subtitles, thus changing the style due to the same zero-shot effect which allowed the multilingual translation to pick up language pairs it has not seen. Now, this is of course cross-lingual, so how do we do monolingual within English or within Estonian change of style but preserving the meaning? So this is only done by including both directions, and Estonian to English, English to Estonian, and doing multi-domain or multi-style and multilingual translation. And then asking the system to translate, let's say, from English into English. So something like, how should I know, in the informal style of English, to ask it to translate it into, well, what did I write there? So we cannot be expected to hold the precise knowledge of something, paraphrased into the correct domain. Maybe I can see it in the mirror. But it's, yeah. What we did is then, for a demo, which I have a couple of screenshots of, we took translation examples in Estonian, Latvian, and English in all 6 translation directions. And we took 4 text domains, which were subtitles representing informal speech, then European Parliament speeches, which are still speech but formal, then legal text, translations of EU laws, and finally medical documentation. And we took about 22 million translation examples to train all of this system, and on a graphical accelerator, it took about a month for this model to learn. But what we obtained in the end is examples like the following here. So we can type an English sentence which was, "Didn't you get the memo?" And we ask the system to translate it to English, but into official language, and it says instead of didn't, it said did you not get the memo. That's of course a very tiny change, and this is something we learned from the process, that it doesn't really paraphrase the whole sentence, but actually does only tiny changes. Now, an example of multilingual paraphrasing, or the cross-lingual style transfer, would be, did you get the memo translated into informal Estonian, where it uses the word sa, so the colloquial or informal you, kas sa memot ei saanud, so didn't you get the memo exactly? And if we ask instead to translate it into official Estonian, first of all, it chooses the polite version of te, and even replaces the memo with a message. So maybe a word more appropriate for this domain. And in Latvian, I can't read it out from here, and most of you probably don't speak Latvian, but in Latvian it also, depending on the style, changes from the singular you or impolite you to formal you, and also even changes the lexicon which is used at the translation. Finally, let me conclude by saying about the paraphrasing first, that it does manage to locally paraphrase and change the style as requested, but more generally, of course, we need to come up with ways of coming up with more diverse paraphrases. And just to conclude more in line with the session and about the best practices, or let's say approaches in science, that since all of our work is done in the domain of applied artificial intelligence, then I guess the message of science would be here that artificial intelligence is best done when it's applied, and also quite nicely done when it's done in collaboration with the industry, and so we should not be afraid of it, but rather apply it in practical cases. So I'll finish by giving credit to my research group and students who are doing marvelous things here, and thank you for your attention.